Hi everybody, Mrs. Pesic here.
And Miss Bella here.
And we are looking at section 10.6, which is our last section in the chapter on trigonometry. It's the law of cosines. Our objectives are to use the law of cosines to find the side lengths and the angle measures of a triangle, and to use Heron's formula to find the area of a triangle. So in the previous lesson, you learned to solve triangles by using the law of sines. However, the law of sines cannot be used to solve triangles for which you have an SAS case, that side angle side, or the SSS case, in which you must use the law of cosines. So let's take a look at the law of cosines here. For triangle ABC, the law of cosines states that a squared is equal to b squared plus c squared minus 2bc times the cosine of a. That means if you were given side B and you were given side C and you were given angle A, you could solve the triangle. You could not use law of sines to do this. You would have to go to law of cosines. All right? And there is an alternate versions of the law of cosines that are here also, and we're going to get to use those in this lesson as well. All right?
So first up, example 1 here, we're going to use the law of cosines. So again, you see I kind of copied them over in the two forms. So there's some here and some here. You're not going to need to memorize these just to use them. And we are going to solve triangle ABC. So when I say solve triangle ABC, it means I'm going to find all pieces of it, just like we did in the law of sines video. So we're starting off with side length A, side length B, and the measure of angle C, which is 32.2 degrees. So if we think about this, what am I going to need to find? We're going to find capital A, the angle A. We'll find capital B, angle B, and we'll find lowercase c, which is side length C. All right, so again, if we had a triangle, if you need a picture, again, you can kind of draw one in here that we know that side A is equal to 8, so here's angle A, that's lowercase a. Side B is equal to 5, so here's capital B, and that's lowercase b there. And angle C, we know this angle is 32.2. And we're finding that side length over there. So if I look at my law of cosines and I say based on what information I have, let's bring that back. Okay, based on what information I have, what should I solve for first? Well, since I know lowercase a, lowercase b, and angle C, I'm going to start off by using this formula right here. So I'm going to plug in and I'm going to actually find side length C to start off. So it's kind of just matching up what we have and solving. So we're going to start off with C squared is equal to a squared plus b squared minus 2 times a times b times the cosine of angle C, which is 32.2 degrees. So we're going to need to do some calculations here, and we're going to find that side length first. So C squared is equal to 64 plus 25 minus, what is that going to be, 80 cosine of 32.2 degrees. So let's go to our calculator and figure out what value that is going to be equal to. All right, so we're going to type in 64 plus 25 minus 80 times the cosine of 32.2 degrees. Again, remember, it's very important that when you enter this in, you need to make sure that you are using the degree symbol. So go ahead and add that in for us. And we're going to find out right now that we have 21.3. Again, think back to where we're at, though. We're over here. That means that C squared is equal to 21.3? 21.3. I need to solve for C, so I need to deal with this square. So I'm going to square root both sides. So back on my calculator, I'm going to square root and either copy down that, or you don't need to retype it, or hit the answer there in blue. So we're going to find out, we're going to round to one spot, that C is equal to 4.6. So side length C is equal to 4.6. So that's one more part down that we have. So we still have two things left to find now. We have to find angle A and angle B. I noticed that 8 is larger than 5, so I'm going to find the larger of the two angles first. And if you look over at this side, kind of over here, this is just alternate forms of the law of cosines, and it's a little bit easier to solve for whatever angle you are looking for. So I'm going to start off by solving for angle A. So I'm actually going to use this top formula right here. I got to scoot this over just a bit. There we go, that'll fit. I'm going to use this formula right here in order to help me find that. So in order to use that, I'm going to need to know what side lengths A, B, and C are, and now I know all of those. So let's actually extend the page a little. Let's drag this down so we have some room and just pop up there so we can see what A, B, and C are. So to find the cosine of angle A, this is the next thing I'm solving for, we're going to say this is equal to A squared, and that was kind of hiding up there, but we know it's 8 squared minus B squared, which is 5 squared, minus C squared, which is 4.6 squared. We just found that one. All over -2 times B times C. So we're going to go to our calculator, and we're going to plug in what this is. Okay, so on our calculator, we're going to start off, let's get up a fraction set up first. So in the numerator, we're going to have 8 squared minus 5 squared minus 4.6 squared. And none of those are negative, so I don't really need parentheses there. In the denominator, I'm going to divide this by -2 multiplied by 5 multiplied by 4.6. So we're going to see that that value is equal to -0.38 or somewhere close to there. So right now we know that our cosine of A is equal to about -0.38 or something around there. Now to find angle A, that means I need to do, I'm saying, what angle has a cosine or an x value equal to this? So to solve for angle A, we'll take cosine inverse of that -0.38. Now I'm not going to round here. I'll use the exact value from my calculator to find that. That's just so I don't have to write the whole thing out right now. So I'll do cosine inverse, which is in the trig key, and then we're going to just copy down that answer we had from above, and we'll find out that our angle, well now it says 1.96. Remember, your calculator gives you answers in radians, so we'll convert it to degrees by multiplying by 180 divided by pi. And we'll find out that angle A is equal to about 112.2 degrees. Oh, 0.8. There we go. Can't read. All right. 112.8 degrees. So we have one last thing here to find. So we now know angle A. We know angle C was 32.2 degrees. So last off to find angle B, I'm just going to know the fact that they all add up to 180. And let's get this out of the way. We'll just write it right over here. So we know that in order to find the measure of angle B, we're going to take 180 degrees, what they all add up to, and I'm going to subtract 112.8 degrees and then subtract 32.2 degrees from that. Again, that will give me the measure of angle B, my last angle in my triangle. So 180 minus 112.8, and then again subtract 32.2, and we'll find out that our measure of angle B is equal to 35 degrees. So again, we've solved this triangle by finding every angle measure in the triangle along with every side length. So we have 6 pieces of information total.
Okay, so now let's look at another example. This example says use the given measurements to solve triangle ABC, round to the nearest tenth. In this case, we are given the 3 side lengths. A is 8, B is 9, C is 7. So if we're going to get a kind of visual of this, we've got, A is 8, so I'll say that might be this side right here. So this is A, that makes this angle A. And let's say B is 9, that might be this side right here. So this is angle B up top. And then this is 7, that's our C, and then this would be angle C. So we're trying to find these 3 angles, angle A, angle B, and angle C. At this point, it's easiest to go with these alternate forms, that we have here. And what we're going to want to do is always start with finding the largest angle. And you know from geometry that the largest angle is going to be across from the largest side. So that's B. So we're going to want to go with this formula right here. Cosine of B of angle B is equal to B squared minus A squared minus C squared divided by a -2AC. So let's write down what that's going to be. The cosine of angle B is going to be B squared, which is 9 squared, minus A squared, which is 8 squared, minus C squared, which is 7 squared, all over -2 times A, which is 8, times C, which is 7. All right, so at this point, we could just clean this up a little bit and say that's going to be 81 minus 64 minus 49 over -2 times 56 right? It's negative 112. So I can write this over negative 112. All right, and so we can go to our calculator. We're going to do 81 minus 64 minus 49, and that's negative 32, and that's divided by negative 112. Is that right? All right, and so we get our answer is 2/7. So that means that we have the cosine of angle B is equal to 2/7. So in order to find the cosine, remember that means that we want cosine inverse of 2/7. That's how we're going to find our angle B. Angle B is the angle whose cosine is 2/7. So we go to the calculator, and we're going to do cosine inverse of 2/7, or of the answer, and we get 1.28. Remember, that is in radians, so we're going to want to convert. We're going to say times 180 and divided by pi. And so we end up getting about 73.4 degrees for this one. So angle B here turns out to be 73.4 degrees. All right. At this point, we can move on and find our next largest angle using our law of cosines. So let's go to angle A, which is across from our second largest angle. So if we're going to go with that, we're going to find that we're going to want to use this formula right here. So if we do this, I'm just going to pull these down so I can do this further down there. Thank you. So if we are going to use that formula, and again, we know that A is 8, B is 9, C is 7. So if I'm going to go to cosine of angle A, that is now going to be 8 squared minus 9 squared minus 7 squared over a negative 2 times 9 times, 7? All right, so that gives us 64 minus 81 minus 49 over negative 2 times 63, which is negative 126. All right, so let's try this. 64 minus 81 minus 49 over negative 126. We get 11 over 21. And so cosine of A is negative 11 over 21. So we're going to do cosine inverse to find angle A. Angle A is going to be cosine inverse of negative 11 over 21. Positive 11 over 21. So we do cosine inverse 11 over 21, and we get 1.02 approximately. So we want to find the we want to convert that to degrees because that's 1.02 radians. So we say times 180 divided by pi, and we end up getting about 58.4 degrees. So A is equal to 58.4 degrees, and we know that angle B was 73.4, so we can find angle C by doing 180 minus 73.4 minus 58.4. So if we go to our calculator, 180 minus 73.4 minus 58.4 leaves us with 48.2. So our final angle then, angle C, is going to be 48.2 degrees. Okay, so your first notes must do is to use the given measurements to solve the triangle ABC, round to the nearest 10. B is equal to 23, C is equal to 18, and the measure of angle A is 170 degrees.
Okay, now other things we're going to use in here is we're going to remind ourselves that the largest angle of a triangle is the angle opposite the longest side, and we just talked about that in the last problem. So we're going to use some problem solving here. If a hiker travels at an average speed of 2.5 miles per hour, how long will it take him to travel from the cave to the waterfall? So again, we already have a picture here. We're going to round to the nearest tenth of an hour. Notice in your triangle, what do we know? Well, we know that between the cabin and the cave, that is 3 miles. Between the cabin and the waterfall, that is 4 miles. And the angle between those two is going to be 71.1 degrees. Now, oh, 71. I cannot read numbers today. Okay, 71.7 degrees. So I want to know to travel between the cave and the waterfall. So really, I'm looking for what this side length over here is in green. And then I'll take into account the speed after I find that. So if I kind of label my triangle here to help me out, well, I know, let's call this A, B, C. Again, I'm just kind of making up what these are. We know that across from this little a, I don't know what that is. Side length B is going to equal 4, and side length C is going to equal 3. So it looks like what I'm looking for is side length A. So it's going to be helpful in this case if I actually go back and bring in some of those formulas about the law of cosine. So kind of that top one right there we're going to use. And we're going to use that to find out what is the side length A that would tell me the distance between the cave and the waterfall. So again, we have labeled what our values are in this case. So we're going to be looking for side length A between the cave and waterfall. So I'll use this one right here. Well, we have 2 copies of it, but that's okay. So let's plug in what we know. We know that a squared, that's what I'm looking for. So a squared is going to equal b squared. So we said that was 4 squared plus c squared, so 3 squared, minus 2 times b times c times the cosine of a, again, angle A right there, 71.7 degrees. So I could clean this up just a little bit. And I could say right now I know that a squared is equal to 16 plus 9. Let's see, that's 8. 8 times 3 is 24. So 24 cosine of 71.7 degrees. Let's go to our calculator and see what value that's going to give us. So 16 plus 9 minus 24 multiplied by the cosine of 71.7. 71. 71.7, and make sure you put in your degree symbol there. So right now we know that a squared is equal to 17.5 or so, 71.5, 71.6, somewhere around there. So 17, not 71 at all, 17.5. So to solve for a, we're going to need to square root. So go back to our calculator. Let's square root. Again, don't retype in the rounded answer, just bring down that original answer so you can hit Control Answer there. So we know that side length A there, we'll round it to maybe 4.2. So we know that A is about 4.2 miles. Look at my units here, 4.2 miles. Now, the question wasn't how far are those apart, but actually how long it will take. So we know that the hiker has to travel 4.2 miles to go from the cave to the waterfall. And they're going to walk at a speed of 2.5 miles per hour. So if I know that they can go that far, again, kind of a little conversion here, in 1 hour, they can travel 2.5 miles. So my miles can cancel out here. Really, it's going to take 4.2 times 1 divided by 2.5 hours. I'm just going to divide 4.2 by 2.5. So if I divide that out, it looks like it will take the hiker, again, rounding, we'll say approximately 1.7 hours to make it from the cave to the waterfall at this current rate. So my final, it will take 1.7 hours. Okay, so our final answer there. So one part using law of cosines, and then just a little conversion in between there. All right, there's your second must do. Same idea. Pilot is flying from Houston to Oklahoma. They're going to go a little off route because of a thunderstorm, and we have the degree that they turn. We also know the other distance that they've traveled. So you're going to figure out how much farther. First off, you're going to find out what is the route between our turning point, Oklahoma City. So find that length first. And then the question is, how much farther than the direct route was this route? So originally the plane was just going to go this many miles to go to Oklahoma City. Once you find that side in red, you have to account for it. They went 175 miles this way and then that direction. So add that and compare it to what the straight route would have been without the thunderstorm.
Okay, the law of cosines can be used to derive a formula for the area of a triangle based on its side lengths. This formula is called Heron's formula. And so for triangle ABC, where S is half of the perimeter, it's like the semi-perimeter of the triangle, which we can find by doing, 1/2 of the perimeter, 1/2 of A plus B plus C. Then we can find the area of the triangle by taking square root of S times S minus A times S minus B times S minus C. It's a nice, quick formula for finding the area if you know the three sides. So let's take a look at this example. We've got a garden that has a triangular flower bed with sides that measure 2, 6, and 7 yards. So the picture might look something like this. Here's 2, here's 6, here's 7, and we want to find the area to the nearest tenth of a square yard. So we first have to find the semi-perimeter, that's the S, and that means we need to take 6 plus 7 plus 2, add them up and divide by 2. Well, 6 and 7 and 2 is 15, so 15 divided by 2 is equal to 7.5. So that's our semi-perimeter, and then our formula says, right here, we want to take the square root of, so the area of our triangle is the square root of 7.5, that's our S, times 7.5 minus A, which is 7.5 minus 6, or 2, or whatever side you want, because we have to do all three. So 7.5 minus 6, 7.5 minus 7, and 7.5 minus 2. And then we're taking that on our calculator. So we're going to do square root of 7.5 times the quantity 7.5 minus 6 times the quantity 7.5 minus 7 times quantity 7.5 minus 2. And when we do that, we end up getting our answer as 5.56 approximately. So we went to the nearest tenth of a yard, so we'll round up 5.6 square yards is our area. All right, so it's a nice, easy way to find the area of a triangle. All right, that brings up your last notes must do. The surface of a hotel swimming pool is shaped like a triangle with sides measuring 50 meters, 28 meters, and 30 meters. So you are going to find the area of the pool surface to the nearest square meter. So use Heron's formula, find that semi-perimeter first, plug everything in, and you should be all good. So make sure you've taken some good notes and done all of these notes must do's, and we'll see you next time.
Thanks for watching.